First, I want to thank both Hitachi and Scania for inviting me to moderate this panel. I'm quite passionate about the right-sized truck application. I think it's going to be a real big innovation that pushes into mining and into autonomy. So the combination of it, of these two great companies, is really exciting to me. Just as a kind of an overarching description of what we're going to do over the next 30 minutes, I have just a couple of questions for these guys, and we're going to talk about the project specifically, but a lot more about the interaction between the companies. A lot of this interaction is being driven by the Open Autonomy standard that Wenco has really put a lot of effort into driving towards. And I think that Open Autonomy standard is also going to pivot some of what we're seeing with the walled garden approach of autonomy in our industry to allow mixing of fleets and mixing of technology products. So that first, if we could get a just sort of brief discussion of the project that was undertaken with Scania and Wenco at a Rio Tinto site to give everyone the context of the interactions, and then I'll have a couple questions to follow up from that.
Do you want me to take on? Yeah, the program is pretty simple by description, pretty hard to do. And what we're doing is we're adding in Scania's 8x4 heavy tipper into open pit operations and doing that full autonomy. And then connect that vehicle into Wenco's FMS system. And then we can enabling operations in a completely new way. And the big thing that we do as well is that we have a lot of intelligence in the vehicle. So normally we have, in the mining industry, we have quite stupid vehicles, but we are also developing vehicles for open road. So we can use that knowledge and technology into the mining industry. So we're putting in more and more intelligence into each vehicle so the FMS system can communicate in a different way to those vehicles. Anything to add, Andrew?
Maybe I'll give a bit of the genesis of the partnership to give us a bit of a backdrop. So Rio Tinto put us together back in 2017 and we'll talk more about the use case that we're focused on specifically, but they put us together back in 2017 for a couple of reasons. Rio clearly have made a big investment in traditional autonomy over the years, but strategically they saw the need for an autonomous solution on a smaller profile, faster speed, independently operating truck. We had our first workshop in Perth in 2017, so it goes back a long time. And of course it was under wraps then for about 6 years and we couldn't talk about it at all. But right from the outset, you know, the goal was very clear, and we'll talk more about that today. Personally, I've been involved in the project since the genesis. First time I've had a lot to do with Swedes, and what I've found is very, very collaborative, very transparent, very honest, very committed, good engineering, good levels of investment. So I had a high level of confidence that Scania were going to be a great partner on this project. Rio were a surprise to me, to be honest. You know, I've had a long history dealing with Rio. Rio were the absolute perfect customer here. And just one anecdote, when we were, you know, bumping our knees a little bit early on, and I thought we could get into some contractual challenges, the key guy at Rio said, you know, there's unknown unknowns, we'll work it out. And I think that's a good anecdote of how we've collaborated on this project, is there's been learnings. It's exciting where we've got to, it's transformational and what it's going to enable. And, you know, personally it's been something that I've got a lot of joy, to be honest, out of being a part of, because it is truly transformational.
Could you kind of contrast the three big autonomy projects you've had opportunity with? You obviously were at Maules Creek with a full Hitachi stack, and then yesterday you had your discussion with the ASI, Epiroc, Roy Hill, and then compare it to sort of the relationship and the way that everything interacted on the Scania project under the Open Autonomy platform.
Sure. I'll start with Maules Creek and HCM. So HCM, as we know, we're surrounded by HCM kit. You know, long-standing OEM, high-quality machines, Maules Creek was a very difficult mine to deploy autonomy. Anyone that's been there would, the geometry of that operation was always going to be really challenging. So, you know, one thing about HCM is they never give up. So they put a lot of investment, a lot of commitment to that. One of the key differentiators that they offer to the industry is mixed fleet, so you can have a combination of autonomous and human-driven machines operating in the same environment, which is definitely a change from some of their competitors. And we're a wholly owned sub of HCM, so we've been involved in that project for quite a long time. ASI we talked about yesterday, ASI now part of Epiroc, we talked about it yesterday. I would say that's another step in that you can have mixed fleet, and that project's going very well. We heard about that yesterday, 30-odd trucks running in pit, traditional, I would say traditional with a different flavour, in that it's large trucks, GPS tethered systems, you know, with all of the same sorts of operating parameters as Cat and Komatsu and Hitachi offer. The Scania project is very different in terms of the profile of truck, but also in the use case. So if we, I don't know if you want me to go into the use case. Okay. So if we look at Rio's iron ore precinct, and initially when the project started, we were going to pilot this at Dampier Salt, so it was quite a tactical type of project. But the Rio Tinto Iron Ore Group, when they got confidence in what, and particularly Scania were bringing to the table, Wenco, you know, we offer a layer of technology and we were an important step, but the big lift here was from Scania. Rio's iron ore belt is about 320 kilometres from one end to the other. They are depleting their resources of iron ore by 300 million tonnes a year. So they need to be opening up new iron ore deposits constantly. Their big challenge is traditional autonomy doesn't work when you have a plan to haul that ore into existing rail and crushing infrastructure. The alternative, of course, is to build rail or crushing infrastructure. And now we're talking about billions of dollars of capital investment. So really, the use case initially, and one of, and there are certainly a number of those, was if we could have a high-speed, level 5, fully autonomous, and you could talk more about that, system, and I can bring that ore from those newer deposits into my existing rail and infrastructure, the payday is worth billions of dollars. When we started the project, the technology wasn't there, the vision was very clear. And where we are now is we're executing on that vision. So we are close to having the ability of using Scania, smaller profile, high-speed trucks, and replacing the need to build very expensive infrastructure. So that's why Rio were very committed to this project. And the investment is significant from all three parties. But it's truly transformational in what we're talking about here. And that's just Rio. And there's a lot of other economic benefits in gold, stranded deposits. You know, you guys can extrapolate. This is really quite significant in terms of a technology step in how autonomy can be deployed in mining.
I'd really like to ask a couple of questions around the 8x4 or 10x4 trucks that Scania is offering. There are a lot of people in mining that aren't aware of it, certainly in North America, because the presence of the 8x4 truck is non-existent in North America. However, I've done work in Brazil, for instance, in the iron ore mines, and you'll see a mine running 8x4s that's directly competing with a site that's running 793 Caterpillars and probably winning. Can you just describe the form factor and some of the benefits of bringing 8x4s even into large-scale mining operations?
You can see it behind us here. So it's we have around 12,000 8x4s out in production today. So it's a very used product, and adding in autonomy into it as well then can, as Andrew was into, reach more deposits that further out, and we can then operate in a little bit different way. So we can create a more efficient operation environment, going more specific on when you dig out iron ore or whatever. You can be more specific on the load. And you can also secure that you have these vehicles electrified moving forward, so you can reach the environmental goals that we all are fighting for. So we have several good things with this product, and as you said, it's 8x4 or 10x4, and that's built on Scania's modular system. So what you can do with Scania's modular system is actually you can custom build your own truck. So you're saying that I want to have a number of axles, what type of engine you want, so you can add in, and we just here produce it. So today you can actually say I want 8x4. You can add in saying I want to have a driver, or I want to have autonomous, and you just press send and send that order into our production facilities, and out comes a autonomous vehicle ready to be delivered to the customer, and having all these benefits that we see to reach different areas in the mining industry, being more efficient. Then of course we have the payload versus vehicle weight that is really good as well.
Andrew, can you talk to the advantage of having a smart truck come into an autonomy system, and maybe even compare it a little bit back to the other two systems that you have experience with? I know that Scania is bringing a lot more intelligence on board, and the truck becomes much more of a true driver as compared to the other autonomy.
Yeah, you know, if we think about the traditional use case in mining, we're talking about a relatively small number of trucks in large mining areas, tethered by GPS, and where that's, you know, and I'm always careful not to say anything other than positive about what Hitachi, Cat and Komatsu have delivered to mining, because it has delivered tremendous value. But the use cases are also quite narrow. And I know in North America, for example, particularly where you have solar flare problems, we have the same issue at altitude in South America, where, you know, miners aren't having as much success when they're relying on GPS as, you know, a critical safety system primarily, but obviously positioning as well. So a lot of autonomy projects haven't been as successful as the flagship, very open Pilbara iron ore deployments, where we see all the stats from. I know there's a number of companies that have really stumbled with autonomy. So if we think about Scania and, you know, a true level 5 system, and there are others, by the way. In fact, there's some very interesting companies sitting in the audience today, George, who are really bringing something quite new to the industry. I always equate it to having a human brain on board, a proxy human brain on board. So the Scania guys with their technology can sense, localise, position themselves and sense their environment. So what does that enable? It enables a safe operation in a much more intensive operation, where you've got a lot more trucks, deeper pits, where you don't have GPS at a level that you would need with a traditional system. And the other thing is the supporting infrastructure is much less. You know, if you look at a traditional deployment of autonomy, 100% comms is non-negotiable. You need to be in contact with that truck all the time. Emerging systems, that's not the case. So you can have a long haul, 50, 60 kilometre haul. What's the speed? 60?
60, yeah.
60. So 60 kilometres, 60 kilometres an hour, independently operating truck. So yeah, I mean, the value propositions are tremendous. One of the things as well, that Peter mentioned it quickly, but I'll reinforce it because it's something that's not intuitive. One of the big value propositions is actually the payload to weight ratio of a traditional truck to a smaller truck like this. So traditionally you're looking at trucks of 2-to-1 payload to the weight of the vehicle itself. Whereas with Scania it's 4-to-1. So what does that mean? Obviously you can haul more ore as a percentage of the gross mass you're moving, but think of the implications of electrification. Much easier to electrify this type of truck than it is, and I'm not saying the big trucks are going to go away, I'm saying it's a different use case. So there's a lot of benefits. I
know this is a little bit off some of the topics we were looking at, but I think the reduction in infrastructure is a huge piece of the system. The allowance for high latency, low reliability networks is a big jump. But I think the Scania right-size truck also has some added benefits in other infrastructure components. The change in workshop requirements, the change in tire handling. Can you just talk a little bit about some of the benefits of the Scanias in those type applications? Is that if you have a remote site, you may not have to truck in tires for ultra-class trucks, which is a non-trivial problem.
Yeah, and starting with saying that it's not actually a competition between our small trucks and big trucks. It's actually different use cases. And for us, as you say, remote operations, then our smaller trucks are easier to handle because then you don't need shipping in big wheels and so on, and the whole service networks is simpler because of the size of the vehicle. So it really tells itself that it's so much easier to have a small vehicle. But also securing that, what I said before, that the smartness of our vehicles is actually in the vehicle, not too much in the cloud. So the vehicle itself can handle so many situations that traditional mining solution with autonomy can't handle. So that also shows that we can then operate in a smarter way, so the service of the vehicles goes down. So we don't need as much service either. So in general, that's what we see moving forward.
Excellent. When we look at, again, these very large truck, large-scale AHS, there's kind of a cutoff point where you really can't have a fleet that's too small. Do you feel that this architecture is going to allow for smaller fleet sizes, mines that might only run 10 trucks, smaller satellite pits that might run 5 trucks? Because typically in the ultra-class deployments, the large deployments, you're 20 plus, 50 plus trucks on a deployment. Do you think the architecture change to this smarter truck, decentralized system is going to help us get autonomy into the smaller mines?
I think that's spot on what you're saying, because with the smaller trucks and with the system integration we have, the setup of a new site is fairly straightforward. It's not massive, so doing with 5 or 10 trucks, that's not a big deal actually. And also with the open communication platform that Wenco has and integrated with our vehicles, then we can do it anywhere into any customer. So adding into the total picture, we can do it with 1 truck and we can do it with 50 trucks. So we have a easy scalable product in that sense. But I think the main part is the ease to integrate into Wenco's system as well.
Yeah, I would just say that the business case for the deployment of autonomy is being, some of the constraints are being removed by what we're talking about here. You mentioned some of those constraints, Ben, that really it was a small subset of the mining industry that could reasonably adopt autonomy. And as I said earlier, a lot have tried and they've failed because they heard the best case use stories, 20% increased production. Well, that's a fairy tale for most mines. They just don't have that ability. We've talked a lot about open systems, and I want to acknowledge that we've got a Scania guy here sitting on an Hitachi stage, and I want to talk about that because miners are looking for ways to improve their operations all the time. We're seeing new autonomy systems, artificial intelligence, electrification, all of these things starting to unlock value. And when we started this collaboration 7 odd years ago, there was great support from HCM because the HCM guys, where they had their very clear goal of deploying the homegrown autonomy into the right environment, they're also very open to the concept of, as Peter said earlier, there's different ways these things can be deployed. But what we're really talking about is this open approach to autonomy. You're not focused on the goal through the lens of the constraint of the technology. You're focused on the goal, the value, and then the technology is now emerging where there's a lot more potential deployments and value. So it was really exciting, you know. I'll share an anecdote if I can. I was down in Chile a few years ago talking to one of the big copper miners who have autonomy. They had all these dots on a map. You were with me, Sergio. We had all these dots on a map. And I asked them, you know, what this was, and they said, oh, they're uneconomic deposits. And I said, okay, why is that? And you can't build the infrastructure, et cetera, et cetera. And I said, what if? And I started talking about this. And they said, well, if you can do that, we can add that to our reserves. If we can haul that ore into the existing infrastructure, they become economic. And here we are. So it's much more than just Rio and iron ore. I get goosebumps thinking about it, right? Because, you know, we know how hard it is to get new deposits up and running, the capital cost. But all those dots on a map, I had the same conversation with Escondida. This is a real transformation on where autonomy can deliver value. We're already talking about other projects in South America. So yeah, it's an exciting revolution, really, in the deployment of these systems.
I think you should add in the heavy aggregate quarries in the States. I think often international mining companies overlook those. You're looking at some of the sites in the U.S. are running 12 million ton a year of shipping tons in a construction materials business, and I think there's a certain desire from some of those companies to be able to be part of the autonomy game, and the ultra-class solutions just won't work for them. So I think it opens a whole other class of mine, like you said, satellite pits, quarries that are running 10 trucks that are forestry would be another one. Yeah, there's nothing saying that a Wenco couldn't dispatch logging trucks in a forestry application. So I think the openness of that is a big driver of value. Not so much at the supplier of the technology, but the mines or the heavy industry that's going to use it can see that more clearly, perhaps than a walled garden of complete vertical stack autonomy. We're sort of getting towards the end here, but I think we had a couple conversations before about value alignment between the two companies and how positive it was. Could you guys kind of wrap us up with just a discussion about some of those relationships and how it worked, what worked well?
I'll start with that. I think, first of all, technology and delivering to the customer is of course, super cool to work with autonomy. But to be able to do so and doing a collaboration, you need to start with the same value base. You need to have companies. You can have a great set of engineers here and a great set of engineers here, but if you don't share the same values and principles, then it's really hard to collaborate. You need to be able to work in the same way. And for example, openness is something we value very, very high. And if you don't have a partner that share the same value, then you won't reach the end goal. So I think the values between Wenco and Scania is very similar. Of course, it's not a 100% match, but it's very, very close to 100. And I think that's why you can have efficiency from two teams, and those two teams actually deliver better together than separate. And in that, I think the Wenco team have always been working in a very open and honest atmosphere with, of course, a lot of knowledge and expertise, but the value base is what we believe is the most important to start with, because technology in the end always solves. But if you don't have the same value and the same principles as a base, then it's really hard to deliver.
Yeah, I would echo Peter's words, but I'll share an anecdote, a story of how that shows up in reality, because everyone talks about values, and we all have these values, but how does it really show up? So 2 years ago, actually almost 2 years ago exactly, it was September 22, a team from Wenco, a team from Scania were on site in the Pilbara at Rio. I was there myself, and we had a key milestone at the end of this week. We had about, I think it was about 4 trucks at the time. It wasn't many, but we were hauling dirt. We had an edge dumping use case, and systems were working well together, and then they weren't. We had a problem. And it was embarrassing because this was the week that at the end of the week we were going to go to get the large funding from Rio Tinto. Our engineers were there, the Scania engineers were there. We started looking at the logs. We diagnosed the problem. There was no pointing fingers. It was the two guys working through the logs. They identified where the problem was. We went for lunch. The guys that weren't doing the real work went for lunch. And we came back and things were working again. So at the end of the week, we were back in Perth and we were having the retrospective on how the week went. And the Rio sponsor of the project, he said, this week we saw why this is going to work. Because when everything's going well, partnerships are easy. When they're not, that's when you know if it's going to be a success. And then Rio fully invested in the project because they had faith that we lived the values and we were very clear on the goal we were chasing. And when things go wrong, people with abilities that you and I don't have, Pete, get in and solve those problems and we get the thing productive again. So that's how it shows up.
I can't think of a better way to end the conversation. I want to thank you guys for inviting me to be part of this, and then I want to thank the crowd that was here to listen to us. I think we're going to be around the booths afterwards if anyone has specific questions. I want
to thank you, Ben. Ben and I have spoken about this as a concept for many, many years. So Ben's done a lot of work making mines capable of safely deploying systems. So, really thank you for volunteering your time here, Ben. You've been very generous and very knowledgeable and been a great mentor for me to teach me what I didn't know.
Well, thank you. Again, please try and find us at the booths if you'd like to ask any questions.
Thank you.